All right, let's use these new properties to solve some real-world problems. So in this question, you have to find the area of a square with a side length of 5x cubed y squared z. So why don't you attempt this on your own? Pause the video now. All right, let's see how you did. So the area of a square is just its side length, s, squared. We know that the side length is 5x cubed y squared z. And all we're going to do is square that. So what do we get? This is just the power of a product property. We're going to distribute the exponent on the outside of the parentheses to all of the parts of the product. So 5 squared is 25. X cubed squared is x to the 3 times 2, which is x to the 6. Y squared squared is y to the 4th. And z squared is just z squared. And so there we go. There is our area. Let's try another one. Find the surface area and volume of a cube with an edge length of 2a squared b. Now I'll get you started on the surface area problem. So remember what surface area is. The surface area is just finding the area of all of the surface of a three-dimensional object. So in this case, there are 6 surfaces or 6 faces to this cube. There's 1, 2, and then one in the back 3, one in the back over here 4, then the top of the cube 5, and the bottom makes 6. So the area is going to equal 6 times the area of one of the faces, or one of the surfaces. And in a cube, all of the surfaces are exactly the same, and they're all squares. So what we're going to do is we're going to take this side length, and we're going to square it, and then we're going to multiply it by 6. So the side length is s, we're going to square s, and then we're going to multiply that by 6. So using that formula, why don't you pause the video and try to find the surface area of the cube. Let's see how you did. So we're going to multiply the side length 2a squared b by itself. We're going to square the side length. We're going to square the side length, and then we're going to multiply it by 6. So the first thing we want to do is we want to distribute this exponent. We want to get rid of that first because exponents come before multiplication in the order of operations. So distributing this exponent gives us 2 raised to the 2, or 2 squared is going to be 4. A squared squared is a to the 4th power, and then b squared is just b squared. And then multiplying 6 by 4 is going to give us 24. And then we have our a to the 4 b squared. And there we go. And then our next task is to calculate the volume. The volume of a cube is much easier. The volume of a cube is just its side length cubed. Remember what volume is. Volume is base times height, or in this case, the length times the width times the height. And the length, width, and height of a cube are all the same. They're all the side length. So volume is just s cubed, whereas a square is just s squared. Volume is s cubed. So this is going to be easy. We take our side length, 2a squared b, and we cube it. So again, we're just applying the power of a product property. We're going to distribute the 3 to the 2a squared and b. 2 cubed is going to be 8. A squared raised to the 3rd power is going to be a to the 6th. And then b cubed is just b cubed. And there we go. We found the surface area of the cube and the volume of the cube. All right, in this last problem, you have to find the area of a circle with a radius of 6a cubed. And I've included the formula for the area of a circle here. If you've forgotten it, it's pi r squared. So why don't you pause the video and try to find the area of the circle on your own. Pause the video now. All right, let's see how you did. So our area is going to equal pi times the radius squared. So we put our pi here. And then in parentheses, I'm going to put the radius 6a cubed, and then I'm going to square it. Now, we're only squaring what is inside the parentheses, the value of the radius. So we're going to use the same property, the power of a product property, to distribute the exponent. So that's going to be pi, and I'll write times 6 cubed, 6 squared, which is 36. And then a cubed raised to the second power is going to be a to the 3 times 2, so that's going to be a to the 6th. And there's our area right there. But I'm going to rewrite this in a standard way. The numeric term always comes first. We write 36. Then if we have any constants like pi or e, we write that second. And then comes our variables. And you'll see this throughout all of mathematics. Let me go through this again. The first thing that you write is your numeric term. Your numeric term. Then what you want to do is identify or write your constants. Remember, constants are not variables. Although we use a symbol to represent a number, the value of this symbol never changes. So the value of pi is always 3.14 off into infinity. It never changes. Though we can't write that number down, we use a symbol to represent its value. But it is not a variable. And then finally come our variables. Now there's only one variable in this term, variable, but it's possible to have several variables. So it would be possible to write this term. Let's say we had a to the 6, b, z, q, y, off, blah, 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 blah. You can have an infinite number of variables if you want, but the variables come last. So however you got your answers, as long as you got this, you're good, but this is our area of our circle.